You're probably looking at OpenTelemetry. You clearly understand that you need to instrument your code, but you would like to avoid touching your code as much as possible. Well, good news. The OpenTelemetry Operator has a couple of features that could help us. If you want to instrument your code without any effort, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of an existing series, the OpenTelemetry, where we already had an episode introducing the concept, the tooling. We had a dedicated episode on how to instrument your code, and we introduced a framework that has been recently donated to OpenTelemetry, the SQL commenter. Today's episode will be focused on introducing the OpenTelemetry Operator. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. First, we will start with an introduction. Then we will see what is the value of the OpenTelemetry Operator. The operator introduced new objects, so we will see them one by one, starting with the OpenTelemetryCollector object. Then we will also introduce the Instrumentation object. Last, as usual, we'll jump into a tutorial. As explained in several episodes related to OpenTelemetry, working with OpenTelemetry requires to consider creating measurements using manual or automated instrumentations. Then we will manage our telemetry data by sending it to an observability backend of our choice. We recently had 2 episodes dedicated to instrumenting your code using OpenTelemetry. We also utilize in several of our tutorials the OpenTelemetryCollector that help us to collect, manage our telemetry data. Like explained in the episode introducing OpenTelemetry, the collector could be deployed in several ways. The first natural way is as an agent close to your application. Then you can also deploy it on the server hosting your application, or as a service that will be in charge of receiving data from various agents and forward it to your observability backend of your choice. The collector has the advantage to be vendor agnostic, which means you can instrument your code utilizing standard OpenTelemetry libraries and avoid adding to your code any proprietary library that will help you to interact with your observability backend. So with the collector, we can keep our code neutral. We will use the collector to transform our data and push it to the right destination. To help us manage our data, the collector allows us to build pipelines for each type of telemetry signals. So we can have trace pipelines, logs pipelines, and metrics pipelines. In the pipeline, we will describe how to collect telemetry data, so by determining which port, protocol we need to listen the incoming data. Then we will process, so we will filter, transform the data to match probably with our observability backend format. And last, we will export the modified telemetry data to one or several observability backends. If you want to have more details on the collector pipeline, check out the episode introducing OpenTelemetry. In Kubernetes, we have deployed in several of our tutorials, the OpenTelemetry Collector has a daemon set. In that kind of deployment, the pipeline of our collector is stored in a config map. To understand the value, let's see 2 main challenges that OpenTelemetry could bring to us. Deploying auto instrumentation can be complicated. Modern applications are packaged in container images. So adding instrumentation to your code requires at the end to modify our business logic by adding your instrumentation logic or libraries or whatever, and then we will have to rebuild that image. So building all the images for all of your application could seem very expensive as a task. Let's say that we have resolved the instrumentation challenge and we have decided to avoid adding any proprietary exporters in our code. We clearly prefer to rely on the OpenTelemetryCollector. So for that, we will push our telemetry data to our observability backend, but we will have to build an architecture of collectors to be able to collect and ingest the measurements at scale. When deploying the collector in Kubernetes, our pipeline will be stored in a config map. The major disadvantage is that any updates of our pipeline requires to restart all the pods of our OpenTelemetryCollector. In case of Kubernetes, the OpenTelemetry Operator will simplify many things, especially when it comes to managing our telemetry data. The operator will simplify the deployment of our architecture of collectors. We may probably want to mix the usage of agent deployment and service-based deployment. Agent will be added to our pod as sidecar containers, and the service will be in charge of pushing the data to our observability backend. So at the end of the day, we will be chaining collectors. So we will have sidecar collectors that will push the telemetry to the service collector, and then the service collector will be in charge of pushing it to our own observability backend. Deploying this in a traditional collector could be pretty hard to create and of course to maintain over time. So we need to modify all the deployment files and add our sidecar containers, and that could be quite challenging. Good news, the operator will help us to automate the process of deploying those agents and managing the updates that we may have in our pipelines. In fact, the operator relies on Kubernetes admission webhooks that will be invoked when pods are created or updated. The webhook will modify the pod object by adding the collector agent. The other advantage is related to instrumentation. We don't want to rebuild all the images of our application. Good news, the operator will help us to automatically inject the instrumentation logic for us. Managing the deployment and managing our instrumentation is possible with the operator, and because the operator introduced two new CRDs, the OpenTelemetryCollector and the instrumentation. The OpenTelemetryCollector CRD will help us to deploy our collector within our cluster. So before describing the various features, let's have a look at the CRD. So here is an example of the OpenTelemetryCollector object. As you can see, the OpenTelemetryCollector has several settings. You can customize the image of your collector, the number of replicas that are required, and the pipeline itself is now stored in a config object instead of the config map that we used to deal with the traditional deployment. And then there is a mode. Mode defines how we would like to deploy the collector. There are three modes available: the sidecar, the daemon set, and last, the deployment. So let's see the sidecar. The sidecar mode will inject the collector to our pods having a specific annotation. And this is the annotation that you will have to add to your workload. The value of this annotation could be either equal to true or false, or to the name of your specific OpenTelemetryCollector object instance deployed in the same namespace as your workload. Which means if you deploy several OpenTelemetryCollector objects with a sidecar mode in the same namespace, you will have to precise the name of the collector in the annotation of your pod to make sure that the right collector will be utilized. You can also annotate directly your namespaces to force the usage of your collector to all the workload that is present in that namespace. The operator will take in priority the annotations defined at the pod level. Then it will utilize the namespace one. Daemon set. The daemon set mode will, as expected, deploy the collector on every node of our cluster. And it will create as well one service to receive the telemetry data of your pod. In this type of deployment, you won't need to add any annotation on your workload, but you will have to keep in mind that all your pods will send telemetry data to your collectors. So you will probably need to size properly your collectors to handle the traffic or adding more replicas.
What kind of place is this?
Deployment. The deployment mode is the default mode, where you can deploy one collector or more depending on the number of replica defined, and one service for a specific namespace. But at the end of the day, you could be very smart and creative. You can combine probably a sidecar mode, OpenTelemetryCollector. So the sidecar will be in charge of receiving the local telemetry data produced by the local pods. And every sidecar collector will push it to a daemon set mode, a collector that will be in charge of receiving all those telemetry data and push it to your observability backend of your choice. Like explained in our episode on how to instrument your code utilizing OpenTelemetry, attaching your instrumentation library requires either to add agent to the start up of your application, in the case of Java, or add a few lines of code to start your application and initialize the trace provider, the collector, and register all the instrumentation library. In order to avoid touching our code to add the instrumentation library, the OpenTelemetry Operator provides a feature that will automatically inject our instrumentation library in our pods. Currently, the OpenTelemetry Operator supports the auto instrumentation on several languages. So it supports Java, Node.js, and Python. The new Instrumentation CRD will be deployed in the namespace of your application that would like to be instrumented. So let's have a look at an example of an instrumentation object. So here we have an example, and as you can see, the objects allow us to configure the exporter, so where to send the data, the propagator, the resource, and the sampler. And we can also customize the way we would like to instrument Node.js, Python, and Java by adding environment variables to configure probably the span processor, the resource, and even you can also precise your custom image for your agents. The propagator accepts a list of propagation configuration. So here is an example. So you can say propagator. Here in our example, we utilize the propagator trace context, bagage, and B3. The sampler could also be configured. The sampler object has a type. The value accepted are the following one. So always off, trace ID ratio, parent-based always on, parent-based always off, parent-based trace ID ratio, Jaeger remote, and X-ray. And the argument that is required depends on the type. So in the case of parent-based trace ID ratio, then you will have to precise a float number that will determine the sampling ratio. Resource object will accept add Kubernetes UID attributes, which is a Boolean. When enable, it will add Kubernetes UID attributes in your span attributes. Resource attributes supports a list of attributes like service name, environment, so you can define whatever you want. This resource object will configure all your spans that are instrumented by the instrumentation object and will add those resources. When using the Instrumentation CRD, you will also need to add annotation to your workload. To enable the injections of the proper instrumentation library, you will have to precise the right annotation. So either in the pod, either in the namespace. To enable the injections of the Java agents, you will need to add the following annotation. So here it is. So instrumentation object OpenTelemetry inject Java equal true in this example. For Node.js, this is the value. And last, we have the following one for Python. Similar to OpenTelemetryCollector object, the value can either be true or false, or the name of your instrumentation object deployed in the same namespace as your workload. These are the current features provided by the operator, but you should expect to have more features in the near future that match the updates related to metrics and logs that may be provided by the community. In fact, if you look around, FluentBit has created an operator that also helps us to configure our FluentBit logstream pipelines. So we could probably imagine the similar features in the OpenTelemetry operator to support logs as well. In this tutorial, we will deploy a vanilla version of the online boutique. By vanilla, I'm referring without any OpenTelemetry instrumentation. So no OpenTelemetry libraries, no open tracing, no open census libraries. Like explained, the operator is currently supporting Java, Node.js, and Python. Therefore, we will utilize the instrumented version of the online boutique service for the service that has been built in C# or Go. We will configure the OpenTelemetryCollector to export the generated traces into Dynatrace. So let's see how this tutorial will be structured. We will need, of course, a Kubernetes cluster, no surprise, the Nginx ingress controller to route the traffic to our application, the cert manager. In fact, the cert manager is one of the requirements to deploy the operator. We will deploy the OpenTelemetry operator as well, a Dynatrace tenant with an API token allowing us to interact with the metric ingest API, the log ingest API, and the trace ingest API. We also deploy Prometheus operator, and we will configure our OpenTelemetry collector. Create an instrumentation object, adapt our deployment of the online boutique to add our instrumentation library with the help of these annotations. In this tutorial, we will deploy two collectors, one acting as a sidecar proxy and one as a daemon set. The sidecar deployment mode will push the data to the daemon set, and the daemon set will be used to forward the generated traces to Dynatrace.
So like every tutorial that we're doing at Is It Observable, there is always a GitHub repository. So here we're looking at the repo related to the OpenTelemetry operator. There are obviously several steps related to this tutorial, and at the end of the day, we're going to install the online boutique instrumented with OpenTelemetry, the one that we used on one of the episodes related to instrumentation, how to instrument your code with OpenTelemetry. And we have another one which has no instrumentation. So I won't deploy everything. It's not part of this episode. So keep in mind to follow the steps. So having a cluster, deploying the Nginx ingress controller, and then we are going to deploy Hipster Shop, K6, and others. K6, in fact, is going to be part of the Hipster Shop. Prometheus is not required, to be honest, but it's just that K6 is utilizing the Prometheus to push their statistics. So if you want to at least have some traffic that produce traces, I would recommend to deploy Prometheus. That will make your life way much easier. So to do that, to be able to deploy K6, within a Kubernetes cluster, This integration relies on a feature flag from Prometheus called the remote writer. So you will have to enable the remote writer. So there is an object with the operator called Prometheus that can modify the configuration of Prometheus. So you will have to edit this Prometheus settings to be able to take advantage of this feature flag. And of course, of cases. Before we do anything, just to remind you, we are going to send traces at the end of the day to Dynatrace. So for that, if you have a Dynatrace tenant, you're good to go. No worries. If you don't have any Dynatrace tenant, no worry. You can go to dynatrace.com. There is a free trial section here. In the free trial sections, you will be able to request for a new trial, and you have your tenant in a few seconds. And once it's there, you can utilize it as for this tutorial. So we won't install any agent, we won't install any Kubernetes operator in our cluster. Everything will be basically measured through the standard OpenTelemetry support. So before we jump to the actual tutorials with the steps related to the OpenTelemetry collector, I just want to make sure that you all have the URL to the repo of the OpenTelemetry operator. So in these steps, there is a getting started steps where you will deploy your operator. And those steps, in fact, are been added in these tutorial steps. So the first thing, like mentioned briefly at the beginning when we introduced the tutorial, the operator relies on the cert manager. So that's why you need to deploy the cert manager. So please apply this part first, and then you have to wait that various services of the cert manager is running, especially the webhook, because the operator will rely on the webhook. Then second step, very easy, we will deploy the operator. So just apply this manifest file. This manifest file will deploy the operator itself, the webhooks, create the various CRDs. Now we are going to send traces to Dynatrace, and this will be done by interacting with the trace ingest API. So for this, you will have to create a token. So I'm just going to remind you, we did it several times on several tutorials. To create a token in Dynatrace, in the left menu, there is an access token, which is here. And from the access token menu, you would be able to generate a new token. So here I'm going to show you. So I'm going to say test, is it observable, because I already deployed everything, so I don't have to recreate it. Test, is it observable? And here I'm just going to select the OpenTelemetry traces and click on the generate token. So here I got a value. I can copy that and use it or save it somewhere, so then I can take advantage in my environment. We are, like described, we're going to deploy two distinct OpenTelemetry operator. So one will be daemon sets. So this one will be in fact in charge of receiving the various traces, and then we'll push it to the Dynatrace OpenTelemetry ingest API. So you can see here we have an OpenTelemetry collector. The name is OTLD in our case, and it's a daemon set deployment. This one here will receive OTLP traces in gRPC or HTTP. There is no processor in this involved here. And last, what we do is in this particular case, we basically export. So we're going to send the HTTP endpoint will be the ingest API of your Dynatrace tenant. And you obviously need your API token here. So make sure to replace those two values. So then you will be able to deploy it. So this one, you don't need to deploy it specifically on the namespace of your app. It's going to be global, but make sure at least to deploy first the daemon set. So as a result of that, if I do a kubectl, so it's been deployed here, and we'll see that in this particular Kubernetes cluster, we have all the pods related to Prometheus because I've deployed it, and GNX. And you can see here we have an OTLD collector. In my case, I have 4 of them running because it's a daemon set. So this OTLD collector is the one for the daemon set. So you see the first part of the name of your pods will be the name of your OpenTelemetry collector object. So if I do now the same thing, but instead of pods, I'm showing the SVC, you'll see that there will be also an OTLD collector. And this one is going to be the service that will be in charge of receiving the traces in this case in gRPC or HTTP, but here we use gRPC. So this, once you deploy, this what you're going to expect. So services, so one for the collector, one headless and one monitoring, and then we have the normal one to receive the traces. So now, then the second thing we need as operator is to deploy another OpenTelemetry collector, like I explained, and this one will be named OTel Sidecar. So you can name whatever you want, but in my case, I named it that way. It's a sidecar deployment in that case. As you can see here, the only thing that it does here, it's interacting with the OTLD, which is our daemon set. So this is a way of pushing back the traces. So I generate trace on the sidecar, so the apps will push the traces on their own sidecar container, so collector, and then each of those collector will push it back to the daemon set. So the instrumentation. So first I have created, in my case, 2 instrumentation because one I wanted to utilize all the various propagators available in the instrumentation library. Python at the moment doesn't have the support of B3. So that's why I had to create 2 distinct instrumentation library, one with B3 and the other one without B3. Of course, if we could rely on only one propagator, one instrumentation. But in my case, I wanted just to take advantage of all the features of the operator. Second thing that I do here, you can see because it's a demo, I use the sampler type always on. But you can also, to minimize the impact of the storage of the traces, you could change it to a trace ID sample ratio-based sampler. And you will have to specify the arguments here. So if we do a trace ID sample, we have to add an argument element with a value. So it's going to be, for example, 0.5, like half of the traces will be pushed to your collector. So here let's of course you have to replace the type, which is not always on, but in our case, if you want to use the ratio based, you will have to use the one that relate to the ratio based. The other thing which is important, I have added a resource section. I'm not adding any extra resources. I'm just want to add in the top of the span attributes all the Kubernetes attributes. So that will attach the pod name, namespace, a couple of crucial information that will help me to understand, especially in my case, because I have 2 hipster shop. The other one, I don't have that option enabled because it's been pre-instrumented. So the difference would be the trace generated from the open operator will have those attributes and the other one won't have those attributes. So as you can see, we have the non-OTel instrumentation object, and we have another object just specific, like I mentioned, to Python, which will have non-OTel Python instrumentation. So 2 objects, which means those will be deployed on the same namespace. So if I show you briefly in the namespace where it will be applied. Then you can see that we have the 2 of those, the non-OTel instrumentation and the one with Python. Those 2 ones are being deployed. Again, in the instrumentation, we're using the default images, but if I wanted, I could have added here a Node.js object or a Python object or a Java object where I would be able to customize the agent that I would like to push into my various containers. So here in this folder, we have the deployment files related to the hipster shop, which would be instrumented with the pure instrumentation. So this is have been built on the previous episode related to how to instrument your code with OpenTelemetry. The only difference what I did here is that those traces and spans will be sent to the OpenTelemetry daemon set collector object that we deployed previously. Now let's have a look at the various annotations. So if I go back to the other one, the other hipster shop, the one that has no instrumentation enabled, where I will inject basically the sidecar. Let's have a look at the various annotation that we have added. So first, we, like I mentioned, there are services in this particular application that are built in Go or in C#. Those are not supported yet with the operator. So those are using the manual instrumentation approach. So here, let's take the email services, which is built in Python. As you can see, first in the template, so you don't add the annotations in your deployment files, you add it in your the template, so the annotation that will be pushed on your pods related to that deployment. And you can see here, I have an open instrumentation OpenTelemetry IO inject Python. So here I'm precising that I want to inject Python, and in this, because we have two instrumentation objects, I don't have true. I'm precising the name of the instrumentation object that I want to use and that is deployed on the same namespace. The second annotation is the one related to the collector. So here you can see that we're using a sidecar OpenTelemetry collector, and similar, because we have two OpenTelemetry collector, I have here defined the name, but again, remember, only the sidecar ones require the annotation, so I could have it left to true, because at the end, in this namespace, there's only one hotel sidecar collector object deployed, so true would also make the trick. So this is for the Python one, but let's take another example. So we have the checkout services, and here the checkout services is a Go. So this is where I use the hotel, the version of the services is already instrumented. Payment services. Payment services is Node.js. So if you look at the payment services, the difference that we have, you can see here between the previous services and this one is just that the annotation, as you can see, it specified the inject Node.js. So here we are precising to our collector that to our operator that we want to inject the Node.js agent and not the Python one. The last example is the Java one. So if I can scroll down, the only Java service that we have here in this OTLP version of the hipster shop is the add services, which is based in Java. And as you can see, the only thing that has been added is the inject Java. So let's have a look at the pods that we have in this namespace, the hipster shop down hotel. So we will expect on all the various pods where we have the sidecar that will be injected to have two pods. So this is the case here. We can see that Java 1 has two containers. Currency is the Node.js one, email services in Python, and so you can see that all of them has the various container injected. So let's describe one of the pods, so the add services on this namespace. So let's go to the top. And a few things we can see. So the first, we have an init container. The init container, this one has been injected by the operator through the rules that we've defined through our instrumentation object. As you can see, that it's grabbing a specific version image for our auto instrumentation Java library, and it will basically, you can see as a command, it takes the Java agent and copy paste it in the container. So the container of our app, which is the add services, will have now that agent. The second thing that it is also doing is modifying the definition of our pod. As you can see, it has a few things. So first we have the service name, the pod name, the pod UID. So all of the things here, those are related to our resource. You remember we had the add Kubernetes attributes to true. So this is what happens. It adds all those extra attributes and resources in the top of our container. The other thing, it's also configured the propagator that the instrumentation should use. And as we can see, as expected, we have the the launch of the Java agent, which is here with the Java options that has been also added. So side of this one, we have our hotel collector. So the collector, it has grabbed the version related to the operator, and also the config object you see here, it becomes a YAML file. So the collector load our pipeline there and will be ready to receive traces. So let's open the trace. And in the trace, I will jump into distributed traces, which is on the left side here in application microservices. In the Hipster shop, I replaced the low-cost load generator by K6 because K6, the advantage, has a plugin called X distributed tracing. So the advantage is that K6 will generate the first trace, the first span, with the get, the various HTTP methods related to generate by K6. So here we have one here. We see HTTP get, and we have the URL. So we have the non-hotel. So this is the application non-instrumented. So instrumented automatically by the operator. So let's have a look at that distributed trace. So we have the traces. This is all the piece related by K6. So we see HTTP get. We can have a few details about the request itself that has been sent. So we can see we're calling that product. And then it goes through, we have the headers, the send methods. So we have a couple of details. And then here we enter into the front end. Front end, to remind, this one is instrumented, is a Go, so no instrumentation. But then we go to product catalog, which is not instrumentation. But then we will have, let's search for the service that may have been instrumented. Oh, here we have the ad services. So the ad services, this is the, here it is. So here, this ad services, this is the one added automatically by the operator. And one thing which is interesting, you can see it has added lots of new resource attributes. So we have the host name, the container, the deployment. We have a lot of things specifically related to OpenTelemetry, to the Kubernetes environment.
So that's it for today's episode related to the OpenTelemetry operator. As you can see, if you are operating a Kubernetes cluster and your applications are running in a Kubernetes environment, the operator makes completely sense. It simplifies so much the deployments of our collectors. It also helps us to instrument our application without any effort. So the operator is clearly a good news for us. But keep in mind that the operator will probably be updated soon because we are waiting for some updates related to the support of logs. And I'm pretty sure that logs will introduce new objects in the OpenTelemetry operator. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So thanks for watching this episode and see you soon for another topic. Bye.